In this video, we will introduce synchronization within the Java programming language. There are many situations in which multiple threads must share access to common objects. Previous examples have used multi-threading by having multiple executing threads write to the Java console, a common shared object. These examples have not required any coordination or synchronization in the way the threads access the console window. Whatever thread is currently executing was able to write to the console window. No coordination between concurrent threads was required. There are times when you might want to coordinate access to shared resources. For example, in a database system, you might not want one thread to be updating a database record while another thread is trying to read it. Java enables you to coordinate the actions of multiple threads using synchronized methods and synchronized statements. An object for which access is to be coordinated is accessed through the use of synchronized methods. These methods are declared with the synchronized keyword. Only one synchronized method can be invoked for an object at a given point in time. This keeps synchronized methods in multiple threads from conflicting with each other. Let's walk through an example. Here we have an array holding our values to print to the console. Our threads run method will call our synchronized list. In our main method, we create two threads and start them both. Basically, we continue to loop while both threads are always alive. Our method displayList has the keyword synchronize, which enables a simple strategy for preventing thread interference and memory consistency errors. If an object is visible to more than one thread, all reads or writes to that object's variables are done through synchronized methods. The displayList method uses the current thread method of class thread to reference the current thread in order to invoke random wait. Now we have to run our program and watch its output. Right-click on the source, run as Java application. It says VTC and Java are hot, rock, and inspiring. Each thread prints out our array of messages. Now let's remove the synchronized keyword in the declaration of the displayList method. And let's see if there's a difference in the program's output and observe the effects of synchronization upon multi-threaded program execution. So we remove the synchronized keyword, right-click on the source, run as Java application. Now we can see here that when displayList is not synchronized, it may be invoked by one thread, say thread 1, display some output, and wait while thread 2 executes. When thread 2 executes, it too invokes displayList to display some output. Two separate invocations of displayList, one for thread 1 and the other for thread 2, execute concurrently. This explains the mixed output displayed. When the synchronized keyword is used, thread 1 invokes displayList, acquires a monitor for the synchronized output class because displayList is a static method, and displayList proceeds with the output display for thread 1. Because thread 1 acquired a monitor for the synchronized output class, thread 2 must wait until the monitor is released before it is able to invoke displayList to display its output. This explains why one task output is completed before the others. This concludes our discussion of synchronized in Java.